Matt, we're here today doing some sales training with you, but I thought, as long as we're doing this kind of background thing with Thermo, why not record it?
Yeah.
And that way, if you're watching as a part of our sales team, or who knows, maybe there's people out there as well that would just like to hear some background information on Thermo and kind of where we've been and how we've ended up where we are. And starting at the beginning of melting Thermo in 2013, Wayne Johnston from WJ Road Marketing and David Sargent from Stripe Zone, Texas, both challenged me to melt plastic quicker. And so we started on a premise of melting plastic quicker. We really didn't understand all the theatrics around how to get a good start and stop, and how to make sure your line thickness was appropriate and proper, how to tightly control temperature. But the big limitation, let's say, in the industry is guys spend a lot of time sitting alongside the road waiting for their kettles to heat back up and melt more material so they can get a lay. Laying is pretty quick, not so difficult. Actually, it's a little more difficult than I thought at the beginning, but the melting time. So, when we started 10 years ago, our competitors were basically taking a kettle that looks kind of like this same shape and putting a fire underneath of it, unless, I love props, so let's just imagine a candle underneath there, okay? There's your candle. And, the bottom surface area of that is 7 square feet. Standard kettle is about 4,000 pounds. So if you do the math, that's 567 pounds per square foot that you're trying to heat. And, when I came along, I knew that I would have to change the metrics of how many square feet of surface area do you have, how many pounds of plastic are you trying to heat with. And so our first kettle was 2 inches around and about 4 foot high, with an auger going down the middle of it. And at first we tried to force hot air into it. In fact, we even built our own turbo combustor to try to force air under pressure to try to make sure that heat was evenly distributed around that column. So where have we ended up all these years later? Well, we've built now 32 trucks over the last 5 years, and those trucks still had vertical melters that kind of shared a hot oil tank in between. In fact, here's kind of a top view of that kettle design. Now, this kettle, we discussed 7 square feet. Well, our current kettle has 22 inches. And if you want to just do the math there at home, I want you to follow along. If you take 22 times 3.147, that's pi, is 69 inches. Divide that by 12, 5.76 feet around the circumference of our kettle, right? And then multiply that times 23 feet long. That's 132 square feet. That's a lot of square. You compare that to 7 square feet, it's a lot of square feet. And now we're heating with oil. So unlike this kettle that only gets some residual heat from heat that's traveling upwards, this kettle is fully oil jacketed. It's a pipe inside of a pipe. If you were looking at the actual kettle, in fact, here's an end view of the kettle. It's a pipe inside of a pipe, so that the top, sides, middle, bottom is all as hot as the rest of it. There's no hot spots in this thing. It's all hot. And then the other thing we do is we have heat exchanger tubes that we force. Once we heat this and we get some molten material, then we begin to force molten plastic up and through a heat exchanger. And as that happens, Matt, we pick up another, I've got the math right here, those heat exchanger tubes are 5/8 of an inch thick, so 0.625. And we multiply that times pi times 3.147. That's 1.96 inch. Now we got to divide that by 12 in order to get feet. So that's 0.16 of a foot around that tube. And then multiply that times 6 feet. That's 0.98 square feet per tube. Like if you cut that tube in half, lay it open, 0.98 square feet, and then there's 122 of them. That's 119 square feet in addition to the 132 feet we get from the sidewalls of this kettle.
And so that's additional heat transfer.
Additional square footage of heat transfer. You know, people say, well, how does square footage have, well, if you had no square footage available to transfer heat, you couldn't transfer any heat, right? So if 1 square foot is able to transfer X per hour, how many BTUs is 2 square feet able to transfer per hour?
It's double.
2X, right? And so on and so forth. And this is how I began 10 years ago to really unwind and leverage the mathematics behind melting. And so if you add those two together, the square footage of the melter itself and the heat exchanger, that's 255 square feet. Compare that with 7 square feet from a MB or Aero melter or MRL melter, multiply it times 4, because that's how they kind of, they just duplicate the inefficiencies of a single melter and duplicate it to 4 melters. So that's 28 square feet versus 255. And in a vertical melter, once that melter is empty, which is the whole point of filling it, is to empty it, right? Once it's empty, when you throw in a bag, where does it go? Obviously it falls to the bottom. But do you have any way to lift that plastic up and smear it around the walls? No. The only way you have for those sidewalls heat to do anything would be to fill it. Otherwise, they're not touching anything. How can they transfer heat into something when they're not touching anything? Contrast that with our lateral melter, and the auger is turning upwards. It's lifting material up, and every other auger, and somewhere around here I have a, but I'll tell you what, just put up on the screen for the viewer there, the auger, and you can see that there's a flat spot welded. Every other spiral, there's a flat spot welded. Those flat spots are designed to lift the material vertically and smear it around the walls of this, so whether the kettle is empty or whether the kettle is full, you're able to access and utilize the melting capacity of that square footage. Very powerful. And so, you know, so what's the result of all this? Well, we just did a run with our latest design here and pushed 9,000 pounds an hour through the melter. I want to be clear, because we did both white and, that's between 2 kettles, white and yellow. But in the white side kettle, we started with 2,000 pounds of plastic in an 8,000 pound kettle. So we intentionally started with a small amount in there so that we could change it out more times, right? Because we're basically creating a scenario where there's no traffic, backcountry road. We're putting down plastic for free. It's an expensive experiment. But so we started with 2,000 pounds in the white side. We added 6,000 pounds of material to that and ended up with 2,000 pounds left. So we changed that material out in that kettle 3 times over the course of an hour. Listen to what these customers had to say about that.
Just witness continuous feed striper put out by Hog Technologies. Just witness 9,000 pounds continuous feed in 1 hour. Temperature start and finishing actually went up. No problems there. Very pleased with what I've seen today for this little trial run.
We're here with Hog Technologies, witnessing the continuous feed behind us. We just watched it put down 9,000 pounds of material and held the temperature the entire time and actually gained about 6 to 11 degrees while striping both lines, yellow and white. So it was a really good test and very impressed.
So basically, you know, we're up there while we're striping, the guys are throwing 2 bags a minute. That's 6,000 pounds an hour ad rate, right? We're striping about 3 miles an hour. So 6-inch 100 mil line, roughly 2,000 pounds an hour, 2,000 pounds per mile. So we're both adding 6,000 pounds an hour and consuming 6,000 pounds an hour, which is why over the course of an hour, we stripe 3 miles and use 6,000 pounds. And take a look at the temperatures. Here's the starting temperature. We started at 10:30 and we ended at 11:30. Take a look at the ending temperatures here. And you can see that over the course of that hour, we actually added 6 or 7 degrees in the white side kettle. And then at the same time, we added 3,000 pounds on the yellow side. So 6,000 pounds plus 3,000, we put 9,000 pounds through that system, through the system in 1 hour, and gained temperatures around the system. The hot oil temperature gained temperature, the yellow plastic came up in temperature. So what is the true throughput of this device? Well, it can be difficult to put yourself in a situation to actually answer that question, but my best hypothesis based on what I know it'll do 9. I think it'll do 10 or maybe even 12, okay? So you're melting plastic so fast. Why? It's not magic. It is the size of fire. We haven't talked about the size of fire yet. But basically, you know, you have this fire. Let's let that represent the fire. And if you had no fire, how much plastic could you heat? Well, obviously nothing. But we're using 1.4 million BTUs in a single burner. And here's one of our burners being built in that coil. And we run oil through this coil, round and round through that coil, travels about 20 miles an hour. So as fast as the heat is coming into those pipes, it's carrying it out of the pipes. Where is it carrying it to? 255 square feet, baby. And so, you know, whereas on a conventional kettle, let's just say on a MRL setup, right? You only want to use white today. You don't want to do yellow. And you don't want to spend all the money to flush out your yellow from your white side and you know, and convert all the kettles to white, right? Can you do that with an MRL setup? No. Can you do that with a Hog setup with these lateral kettles, 2 individual kettles? Yeah, all you got to do, shut your white oil valve off, or shut your yellow oil valve off, force all your oil into your white side. Now you're using your 1.4 million BTU all on one color, and increasing the throughput you're able to push through that one color. So it's an amazingly versatile system. If you're running one day to the next, hour and a half startup at most. If you let the kettle sit 3 or 4 days, okay, you're gonna be that probably 2.5, 3 hour startup window. But once you start up, man, wow, this thing is a melting beast. And I am convinced that forever the world of thermoplastic will be changed through this device. We've touched on some of the basics. We'll come back a little bit later today and continue with a second session. So go get a cup of coffee, take a break, relax the mind, and let's go forward from there.